Hello everyone. Today we are going to discuss a new topic, correlation ratio. Already we are discussed earlier what is correlation, what is a rank correlation. So now what is the use of rank correlation? We discuss one by one. So today we are going to discuss a few topics about first one is objectives, second one is introduction, third one is correlation ratio, fourth one is measures of correlation ratio, fifth one is properties of correlation ratio and example problems. So what is the objectives of today's study? That is important. So what is the objectives of correlation ratio? After studying this unit, you should able to define correlation ratio, find the correlation ratio for the given data, know the limits of the correlation ratio. These are the main objectives of the today's lesson. Introduction to correlation ratio. The correlation coefficient can be computed, tells about the extent of association between them. However, if the variables are not linearly related, but some sort of curved linear relationship exists between them, the use of correlation coefficient or may be very low or even 0 or even perfect. In that case, we cannot decide nature of the correlation. So what is the correlation ratio actually? The correlation ratio is coefficient of non-linear association. In the case of linear relationship, the correlation ratio is denoted by eta, becomes the correlation coefficient. In the case of non-linear relationship, the value of the correlation ratio is greater and thereafter the difference between the correlation ratio and the correlation coefficient refers to the degree of the extent of non-linearity relationship. So, which relation is existing while you discussing this? In case of non-linear relationship is existing between the ratio, correlation and ratio of the coefficient. Next topic is measures of correlation ratio. The correlation coefficient measure the linear relationship between given two random variables in terms of x and y. The correlation ratio measures the non-linear relationship either positive or negative between the given random variables x and y. Already you know that correlation existing between the two random variables in terms of positive correlation or negative correlation or either is perfect correlation or zero correlation. In this case, the non-linear relationship we can find the unique values of two random variables. In correlation ratio of y on x, for any unique values of x, for any unique value of y, we can find non-linear relationship for the different possible values of a random variable. Y is given as follows. When we go for correlation ratio, now we are taking your x variables and y variable values. X variables are treated, y variables you can treat it as y1, y1 2, y1 3. This you can take the matrix. So there is a table, matrix table. Okay, if you can adding these table values, first row is existing what? First row is we can identify the y1 bar value. How to find the y1? So the means of the y1 row, y2 row, y3 row and so on, yn row, ym row. So what is the ym bar value? So you can take 1 by nm summing over I is equal to 1 to m yi mj values. Okay, this is the table. By making use of this last column is represented by mean values of this table. So how to, from the above table we should find out the y bar value. Already just now I said how to find the y bar value. Y bar is nothing but what? Mean of the given table. How to find the y bar? General formula is yi bar is equal to 1 by ni into summing over j takes a values 1 to ni yij. Let us assume equation number 1 this. Then total mean can be calculated as, how to add the total mean? We can adding all the summing values, that is y1 plus y2 plus and so on. How many rows are available with us? Total m rows are available with us. We can adding mean 1, mean 2, mean 3 and so on, mean m values. That is nothing but a y bar value. How to get the y bar? Y bar is equal to 1 by n1 plus n2 plus and so on nm summing over I is equal to 1 to m summing over j is equal to 1 to n into yij. If I take the I takes the values where to where? I takes the values 1 to m and j takes the values 1 to n here. Finally, we got n bar. We know that n1 plus n2 plus nm we can treat it as a what? Total, that is treated as a 1 by n. So, therefore, y bar is equal to 1 by n of summing over I takes a values 1 to m and j takes a values 1 to n into yij. If I calculated these values, we got total mean of the given data set. So, for that purpose we can calculate this mean value. Now, total mean I say, just now I say total mean is equal to y bar is equal to 1 by n into summing over ni into yi bar from 1, equation 1. The correlation ratio y on x can be defined as eta square of y on x is equal to 1 minus sigma ey square divided by sigma square, where sigma square ey is the variance of the expected values of variable y. It's understand, once again I am repeat this, where sigma square ey is the variance of expected values of variable y. And generally we know that sigma square is what? Here sigma square is the variance of a variable y. Okay, it's clear for us. So, sigma square y is the expected value and sigma square is the variance of the given variable y. Let us consider sigma square y is equal to 1 by n into summing over I takes the values 1 to m, j takes the values 1 to n, yij minus y bar whole square. Okay, now this I can write another form here. You can adding and subtracting with the y bar yi bar. So, then I convert into new formula, that is 1 by n into summing over I is equal to 1 to m, j takes the values 1 to n, yij minus y bar, already we have y bar. Then what I am doing here, I can adding yi bar minus yi bar plus I bar minus r, same function will get, but ultimately I want to establish a new formula for this. So, if I adding, summation is applicable for both function, we can adding the summation for your 1 by n of summing over I is equal to 1 to m, j is equal to 1 to n, yij minus yi bar whole square plus 1 by n into I takes the values 1 to m, j takes the values 1 to n, yi bar minus y bar whole square plus 2 into 1 by n into summing over I takes the values 1 to m, j takes the values 1 to n, yij minus yi bar into yi bar minus y bar. If I know this, we can simplify this above expression, we got this. So, 1 by n into summing over this function is I takes the values 1 to m and j takes the values 1 to n. Okay. Now, yij minus y bar minus yi bar whole square. This I can write here, what is here, actually this is 1 by n into again same function. Here this function will be, this summation is extended applicable for both functions, I can segregate these two summation values here. First summation I can consider here 1 by n into summing over I takes the values 1 to m, yij minus y bar into 1 by n into summing over j takes the values 1 by into y. So, actually we know that this value becomes what here, 0. If I multiply with this complete function is 2 into 1 by n into this function into 0, this values goes to 0. In that case, we got sigma square y is equal to sigma square ey plus sigma square my. Why I am taking the my? It's I takes the values 1 to m. So, both side I can divide with sigma square y. If I divide both side, I can divide with sigma square y by sigma. If both side we can multiply, the nature of the function does not change. So, that is why, because I would like to convert into establish the relation y on x. Okay. If I divide here, so here sigma square ey by sigma square y plus sigma square my by sigma square y square. So, sigma square y sigma square will be cancelled, it becomes 1 is equal to this term. Okay. So, now one term is coming to here, this is, we can transpose the terms here to here, here to here, here to here, then it becomes what, 1 minus sigma square ey divided by sigma square y is equal to sigma square my. sigma square m square my divided by sigma square y. So, therefore, we can get eta square is equal to what here? Sigma square my divided by sigma square y. You can remember this formula. This is the relation between this. So, where sigma square my is equal to what is the formula? 1 by n into summing over I takes a values 1 to m ni into yi bar minus y bar whole square is the variance of expected values of variable y. Earlier we discussed this. Sigma square my is what? Expected values of variable y. What about sigma square y? Sigma square y is equal to 1 by n into summing over I takes a values 1 to m, j takes a values 1 to n, yi minus y bar whole square is the variance of a variable y. Here we are talking about two variances. One is expected values, expected variance, another one is variance of the given variable. Now, the correlation ratio y on x is given by eta square of y on x is equal to 1 minus sigma square ey divided by sigma square y is equal to sigma square my by sigma square y. So, for easy calculation we can change the variance formula and substitute these values in eta square on y on x formula. Sigma square y becomes what here? 1 by n into, because sometimes direct calculation is very difficult to us. It is a time taken process. In that case we can go for, we can change the variance formula sometimes. Here the two types of changes, one is step deviation method, otherwise we can go for direct calculations here. Sigma square y becomes what here? 1 by n into summing over I takes a values 1 to m, j takes a values 1 to n, yi square minus n into y bar. Already you know that what is n here? Total sum of the total. That means n becomes what here? n1 plus n2 plus n3 plus y bar becomes what? Mean of the given variant, given data set values. Okay. Now, we are talking about second function. What is that? Sigma square my. Sigma square my is equal to 1 by n of summing over I is equal to 1 to m ni into yi bar whole square minus n into y bar square. So, in case of grouped data, just now we discussed. So, grouped data, it is a very easy concept, because if your observations are more, in that case calculation is very tedious to us. In that case we can use grouped data concept. In case of grouped data, the correlation ratio y on x is as follows. Eta square y on x is equal to sigma square my divided by sigma square y. You know that sigma square my formula. In that case here 1 by n into summing over I is equal to 1 to m fi into y bar whole square minus 1 by n into summing over I takes a values 1 to m fi into yi whole square. Since the given data is grouped data, we can use step deviation method. Just now we discussed about that thing. So, how to we can deviate the given data set? So, what is the formula for deviation set? In that case we can use deviation means dy is equal to yi minus b by k. So, what is the yi stands for what, b stands for what, k stands for, in detail I explained here, where yi is the mid values of class interval, given class interval mentioned in your problem. Already we I shown the table in the previous slide. Okay. B is any arbitrary value. Here we are taking any arbitrary value which is based on the interval. Okay. You can choose appropriate b value. After choosing this, we can identify the k. K is the width of the class interval. We can identify the, based on the given data set, we should identify the what is the value of the k. Okay. So, yi is the mid values of the class interval, b is any arbitrary value, k is the width of the class interval. What about n? N is equal to total frequency. Why we are talking about frequency here? Earlier we are taking using the word observation. Here we use the frequency. That how we will get the total frequency? Adding, summing over all the fi values. I takes a values 1 to n. So, n is equal to total frequency. In that case, how that formula is changed? Grouped data formula is changed. Sigma square y is equal to 1 by n into summing over I takes a values 1 to m fi into d square y minus 1 by n of summing over I takes a values 1 to m fi into dy whole square. Okay. So, then sigma square my. Sigma square my is equal to, how we will get the sigma square my? We can use this formula. What is the formula here? What formula is explained to us? So, 1 by n of summing over I is equal to 1 to m fi into yi bar whole square minus 1 by n of summing over I is equal to 1 to m fi into di whole square. Already you know what is a di, what is n, already we explained in detail in previous slide. So, now we are talking about properties. After derivation of the formula, we go for few properties. Why? Because properties are very important, because if you know the properties, we can expect what is your answer to, if you are getting the solve any problems. Based on these properties, we should identify the nature of the function. Okay. So, now we are talking about few properties of correlation ratio. The first two properties, foremost important properties, already you are aware of what is the correlation coefficient. Correlation coefficient is always lies between -1 to +1. Here also the limit of the correlation ratio is lies between -1 to -1 is less than or equal to eta of y on x is less than 1. So, the correlation ratio is always lies between -1 and +1. The correlation ratio is never less than correlation coefficient. The correlation ratio is never less than correlation coefficient. Now, coming to third property is the value of eta y on x is not independent of the classification of the data. So, not independent of the classification of the data. We need to find what? Y on x, eta on y on x. So, now we are discussing few example problems which is related to how I derive the formula, how we can apply these formulas in real time example. These are the real time example, how to solve, how to identify or how to calculate or how to find the correlation ratio of the given data set. So, now my first example problem is find the correlation ratio eta square on y on x for the given data. Here three columns are, first row is represented by class interval, x values here 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Frequency values, what is the frequency values already clearly mentioned here. So, frequency is represented by fi into ni. The frequency values are 5, 3, 2, 4, 3. Now, individual mean values are mentioned here. Y bar yi bar is equal to 8, 3, 4, 6, 5. So, given variance of y is equal to 9.61. So, clearly mention your problem, what is the data set? This is the given data set. What they are asking here? Find the correlation ratio. So, for that we are getting the how to calculate this, already you know the procedure. So, for that the solution of the above problem is the correlation ratio y on x is given by eta square on y on x is equal to sigma square my divided by sigma square phi. Already you know what is sigma square y. Sigma square y is equal to 1 by n is 1 by n into summing over I is equal to 1 to m, j is equal to 1 to n, yi whole square minus n into y bar square. Again one more notation is available in our numerator, sigma square my. So, what is the sigma square my formula? 1 by n is equal to sigma square my is equal to 1 by n of into summing over I takes a values 1 to m, ni into yi bar whole square minus n into y bar whole square. Now, which values you need to calculate according to this? We need to find out the n value, then we need to find sigma square y value and sigma square my value. So, making use of above two formulas, we need to calculate appropriate values. Now, we can check here. So, given that variance of y bar is given to us, what is the variance of y bar here? Sigma square y. Sigma square y is equal to 9.61, already mentioned in your problem. So, what is your class interval? 0 to x, its take as a 0. So, now frequency is also clearly mentioned in your problem. We need to find 0 to 10, what is the frequency value? 5, 10 to 20, 3, 20 to 30, 2, 30 to 40, 4, 40 to 53. Total, we can adding these total frequency. What is the 5 plus 3 plus 2 plus 4 plus 3? That is treated as a total frequency. N is equal to how much here? That is 17. Then this third column is already given in your question only. What is that? Y bar I. Y bar I values are, what are the Y bar I values here? 8, 3, 4, 6, 5. We can adding this total also, because we need to find summing over yi bar value. Summation of yi bar values are 26. Now, now after getting the first, second, third column, we need to find what, ni bar into yi bar. So now n is, what is n value? This is the n value. So 5 into, we can multiply second column into third column, will obtain fourth column values. You can check it we have 5 into 8, how much here? 40. 3 into 3, 9. So 2 into 4, 8, and 4 into 6 is 24, and 3 into 5 is 15. Again we need to adding these all the observations. How much here? 40 plus 9 plus 8 plus 24 plus 15. It is summation ni into yi bar value, it is 96. Now we can go for the next column. What is the next column value? Which value is required? yi bar square is also required according to your formula. So now yi bar means what? Third column squaring terms. Squaring of third column values. What is the yi bar value? First one is 8. Squaring of 8 is 64. 3 square is 9. 4 square is 16, and so on. We will get last observation is what? 5. 5 square is 25. Again we can adding summing over all these values. What is this? 64 plus 9 plus 16 plus 36 plus 25. How much it is? It becomes 150. It is represented as per notation. It is summation yi bar whole square is equal to 150. Finally, we go for the last column. What is that? ni into yi bar whole square. Already we got yi bar square value and n. So what is n value? 5. 5 into 64, 320. 3 into 9, 27. 2 into 16, 32, and similarly we can get 3 into 25 is equal to 75. We can adding these total 322 up to 75, it becomes 598. 598. So making use of this table, so we got all values. From the above table we got total n is equal to how much? 17. Summation yi bar value is 26. ni into y bar is equal to 96. Y bar summation y bar I square is equal to 150. Summation ni into y bar square is 958. These value can substitute in our appropriate y bar. First we need to find out the y bar value. What is the y bar formula? 1 by n into summation ni into y bar. Already you know what is n. Total frequency is equal to 17. So 96 divided by 17, we got 5.6. Now we got all appropriate. First we need to find which we need to calculate sigma square my. What is the sigma square my formula? 1 by n of, already we have to 1 by n. What is n? 1 by 17. Sigma ni y bar square, from the above table we got, what is the value of this one? 598 minus n is equal to 17 into y bar square, just now we got it. What is the y bar square value? 5.6. These values we can substitute here. On simplification we will get sigma square my is equal to 3.81647. Keep in mind this. Now we need to find another function value. What is that? Sigma square y, already we got it. So these two values we can substitute in our known formula. So that is y on x, that is sigma square my divided by sigma square y. So sigma square my already given in your question. What is the value? 9.61. So 3.81647 divided by 9.61, we got 3.9714. This is the answer to the above mentioned question. Now second example is find the correlation ratio on y on x for the following data. X representation, y representation here. So what is the values? 0 to 10, 3 to 3, 2 dash, 3 dash. Dash means there is no value. 8, 4, 2. Which interval it comes under here? 20, 30, 30 to 40, 4 to 3. And 40 to 50, 6, 3, 2. Okay. Now solution for the given data is for which type of data? It is a grouped data. We can use the step deviation method. Already just now we discussed. What is the sigma square? Sigma square y becomes this one. Sigma square my is equal to this. So what is the sigma square y? 1 by n of I is equal to 1 to m fi into d square y minus 1 by n of summing over m fi into dy whole square. Sigma square my is equal to 1 by n of summing over I takes a values 1 to m fi into yi bar whole square minus 1 by n into I takes a values 1 to m fi into dy whole square. Now we can find out the appropriate values for making use of di. We know that yi is a mid value, b is NB arbitrary value, k is the width of the class interval, n is equal to total frequency here. Now class mid values 0 to 5, what is the mid value? 0 plus 10 by 2, 5. 10 plus 30. So now we can check the mid values here. Mid values are what? 5, 10, 25, 35, 45. Now I am going for taking the step deviation here. Step by deviation formula is what? yi minus b by k. So my k value is what? 24. B value is 25. Now so yi is what? 5 minus 25 by interval width is what? 10. Okay. So 20 by 5. It's 5. So what is the value here? So interval is 5 minus 25. 5 minus 20 is minus 20 by 2 is minus 2. So like we can calculate these values. What is minus 2, minus 1, 0, 25 minus 20, 0 by something is 0, 1, 2 like this. So these are already givenly in your question here. 3, 2, 3 are first row frequency values. 2, 3 are, so these are the given frequency already mentioned in your question. Now we need to find what? F value, Fi value and Fi d square value, y is equal to this. Okay. How to get the F value here? Total frequency already clearly mentioned. Fi into d means what is the here? Already we know that what is the value? Minus 2 into 8 minus 16, minus 1 into 5 minus 5, 0 into 14 is 0, 1 into 9 is 9. Okay. Now next we get squaring terms. Squaring means what is the squaring term here? Minus 2 whole square. Minus 2 whole square is 4. 4 into 8. So 4 8s are 32. Then here same thing we can calculate this. Total is 47, 10. Now we can get the yi bar value. Already know yi bar means what? Fi into dy divided by fi. 32 divided by your frequency. What is the frequency here? Already we know that. So now we can calculate the fi into di. What is fi di value? Minus 16 divided by our total frequency. What is that? Minus 16 by 8 is minus 2. Now squaring up this is 4. Now again fi into d square, that means this squaring. Finally we got what is the last column is represented here. So 47, 10, 90, 0, 10, 90. So above using above values, from the above table we observe that b is equal to 25, k is equal to 10 and n is equal to 47, total frequency is equal to 10. So finally all those values you can substitute in formula, then we get this. So first one is sigma square my is equal to this. Finally we got total square value. So now sigma square y on x is equal to 1. Finally, we conclude here. The present we are discussed introductions of correlation, measures of correlation ratio, properties of correlation ratio and example problems in the present discussions. So thank you all.